Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with LearnBay.co. Happy learning!
Okay, so I want to move to topic modeling now. And okay, what is topic? If in the most plain English, if I were to ask you, what is topic exactly? Anyone? How would you describe or what would you say when I say the word topic?
It is the general direction of the discourse. As in, it gives an idea of what exactly the single line of 4-word summary of what the whole thing is.
Yeah, what is the matter or what is the major subject in the text? That's what topic means really. So why do we require topic modeling? Or why do you want to know the topic of the subject or topic of the conversation?
In case of AI, maybe we want to segregate things on the basis of topic.
Basically, very good answers. Segregation at the end of the day, because we have huge amount of textual data. Okay, like I think the estimate says like 70 to 80% of data that is available around the world is mostly unstructured. Okay, and most of it is again in textual format anyways. Okay, so in form of news article, research papers, social media posts, and we may need to design, organize, and label this data to make informed decisions. And if you think about it, topic modeling is utilized in various questions, and again on Stack Overflow to find the questions and answers which are similar to each other, news flow aggregation, recommender systems. Okay, in all of these, the core idea is to find the hidden thematic structure in the text, figure out what topics they are dealing with, and maybe segregate them. So one of the most standard ways of doing topic modeling happens to be a technique called latent Dirichlet allocation, developed by Professor David M. Blay in 2003. Okay, so it is basically, if you really think about it, and now again, I will just explain you the basic idea because maths might not make sense immediately to everyone here, but still I will give you a good idea that what is happening. It's fundamentally a Dirichlet allocation at the end of the day, which is basically nothing. Okay, why is the RAM up all of a sudden? Yeah, this is very weird. Okay, now it will go down. Okay. Okay, all right. So the idea is, and now this is basically Bayesian. Okay, the fundamental idea is this is a Bayesian allocation, or this is the Bayesian idea itself. So let me just show you a simple picture and hopefully it makes sense. Now the overall mathematics still will take a lot of time to digest, so I'm not going to go into in depth with everything immediately. But the basic idea is very simple, that every document has its own probability distribution. As you can see here in this picture, that what we have tried to show you is every document has to have its own probability distribution of different topics. Let's say these three colors represent different topics. Okay, so the idea is to figure out that these topics which are distributed over words exist for whole collection. Okay. And again, each document is generated and basically you figure out the distribution of topics, this one histogram. And then for each word, then you do a topic assignment. So for each word, you try to figure out this word might be dealing with which topic itself. Okay, like this one. So you want to figure out gene, DNA, genetic, life, evolve, organism, brain, neuron, nerve, data, number, computers. What topics these all words might be getting categorized as to. So the idea is, if you could figure out the correct distribution of topics, you could figure out which word belongs to which topic. And based on this probability distribution, we can assign, or we can do our Bayesian update, and we can figure out ideally with the overall text or overall document might be containing what topic and what words actually identify with that topic. Okay. So remember, there is three things: latent, Dirichlet, and allocation. Latent means everything that we don't know a priori and are hidden in data. Okay, so we understand there are topics, but we do not know which ones. Okay, so that's why it is latent. Latent means hidden. Okay, and based on the scanning of the text, or when you go through the text, you are like, okay, we can figure out few topics, no doubt. We can figure out these different topics, but the idea is overall text is just a kind of a distribution. So I know it might be kind of a hard thing to get around your head immediately, that the idea is the text at the end of the day, ignoring stop words and your frequently occurring words, is basically just gonna be drawn out from a distribution. Now, of course, this might be a revolting idea to think about, that how possibly it could happen. But that's the idea behind latent Dirichlet allocation itself. That let's say there are 4 topics in this one. Let's say this is sports, this is politics, this is your daily news, and the final one happens to be, oh, let's say world news. Okay, so what if I say a newspaper will be just consistent of these 4 topics only? And fundamentally, if I can identify the correct words associated with each topic, I could reconstruct a newspaper back almost. Okay, I can almost reconstruct a newspaper, or I could reconstruct an article itself, because each article or each document has a probability distribution. Now, it's a big assumption, first of all. It might not always be true, but this is the assumption on which LDA even works on. Okay. Now, once you talk about distribution, it is very easy. So Dirichlet means it's a distribution of distribution. So for all the distribution, there is a distribution. Okay, basically the idea is we control, or let's say basically it's a random machine. Okay, so you generate all these random numbers. So there must be a machine to generate all these random numbers. So that's what Dirichlet is fundamentally. Basically, it controls, or it knows, the distribution of all the distributions. Okay, so in context of topic modeling, Dirichlet is the distribution of topics in each document and distribution of words in the topics. Okay, and once we will look a bit further, you will understand what Dirichlet fundamentally what we mean. And allocation is that once you have Dirichlet, again distribution of distribution, we just allocate topics to the documents and word of the documents to topics. That's all. Okay, that once you figure out this distribution, or all the distribution that can be found, then it is a simple matter of just allocating right words to each topic and assigning topics to each document. And you can just reconstruct any, or almost figure out any document based on this assumption. Now, again, remember, I'm saying the word assumption. It might not always be true. And of course, for stop words and a lot of things, it doesn't work very well. But you get the basic topic. Now you have to understand, we are talking about topics. We are not talking about text generation. So be careful here. So my idea is you will be able to get the correct topics associated with each document or each classification. I'm not saying you will be able to regenerate the whole text. That's not how it works, but it will be very close enough. And I will show you a couple of examples, and you will see it is very close enough what it can generate. Might not be same in the meaning, but very close enough in order to understand the topic. Does everyone follows me so far? So the idea is a probability of word given topic, okay, per document, given topic and document, is basically the idea is probability of word given topic and document into probability of topic given per document. Okay, so T is the total number of topics. Okay, and let's assume there are W number of words in our vocabulary. And if you assume there is a conditional independence, which is again not true all the time in documents, there might not be a conditional independence. We can just say that this equation, or hence P word given document is equal to, is just a Bayesian update, that basically what we are doing. So basically what they are saying is probability of word given each document is nothing but summation of probability of word given topics and documents into probability of topic given documents. Okay. So that's what basically they are trying to aim, or they basically claim here, and saying that because these things are independent of each other, topic and documents are not conditionally dependent. I could very easily write like this: word given topic into probability of topic given document. Okay, that's it. So this is your basic standard Bayesian that we are basically applying, and we are saying that if assumptions hold true, probability of word given per document can be basically determined. Does this make sense?
We are talking about one document, all right? We are not talking about multiple documents.
Right now I am talking about one document, but this idea can, because Dirichlet is distribution of distributions, we can expand it to various other or collection of documents. It is just not one. After a while, it will, of course, it will change document to document. I'm not saying that, but I'm saying it can be calculated.
Okay, but then all the set of documents we will take as one pool.
One corpus, yes.
Yeah, okay.
So the idea is to figure out topics in each document. What each single document deals with what topic. And this is the basic idea, that a word or a document structure is nothing but, if you think about, if this is a word given per document, if this one, let's say, is a word, okay? So basically it is just simply thought as two ideas. It's a very simple idea, that word given per topic. So per topic, there would be set of words. So let's imagine this word happens to be dog. And there are various topics. There is a list of topics. So this is about pets. And pets, dogs happens to be one of the words in pets. There could be cats as well. And then we have these our documents for each topic, or sorry, topic given document. So for their the distribution of topics exists in each document. So this document, or this might be for pets only. And in that weird intersection, you come to find that if I know distribution of words given per topic, and then if I know distribution of topics given each document, I can approximately sample dogs or whatever word was to arrange or come here through a simple Bayesian trick or Bayesian update. Okay. Okay, so let me give you a bit graphical, because I know that maths makes people very queasy at the end of the day. Okay, now remember, again, similarly what I told you, what was true for, if you remember, Levenstein's distance, these, again, because these deal with sequences, right? So it is just not your NLP data. You can apply in DNA, nucleotides, pizzas and toppings, molecules and atoms, employees and skills, keyboard and crumbs. So the idea is you can actually use this idea in a lot of other other discussions and other ideas and domains as well. So LD actually has found a lot of uses in biology as well. Now, basically what you have to do is you will have to come up with a probabilistic model or probabilistic topic modeling. So it will go like this. The first table describes the probability or chance of selecting a particular part when sampling a particular topic or a category. Second table describes the selecting a particular topic when sampling a particular document or a composite. Let's say this is the example. I suddenly have a taste for bacon avocado toast. Okay, what do you think the topic here is? Now, topic might not be very clear immediately, okay? It might not be a word exactly that even might have been mentioned altogether. Can you tell me what is the topic here?
Food.
Food, hunger, yeah, you can talk about food mostly. Let's say there are a couple of documents. In different documents, there is a different frequency. So this is bread, this is avocado, and last one is bacon. So in document 0, bread comes 10 times, avocado 0, and bacon is also 0. Similarly, you can see if I present 4 different documents, I am getting different kind of distribution at the end of the day for each bread, avocado, and bacon. Okay, so this is the distribution of these few words. Now, in document 0, you can also visualize, if you wanted to visualize it as such as document 0 is mostly consisting of bread, 1 is consisting of avocado, 2 is consisting of bacon, and document 3 happen to have all three of them. Okay, so this is the correct this is the distribution right now. So if I say it's not very hard to visualize. For document 0, what the distribution looks like, guys, come on. So the distribution is, let's say I put bread first. This is 10 and rest of them are just 0. So I will just draw like a blank here. Make sense? Now for document 1, what is the distribution?
0, 10.
Yeah, very good. So it's not very hard to visualize. So this will be flat. Next one will be 10. And then the next one is again flat. And similarly for the last one, I'm just skipping the third one. I hope everyone understands that anyway. So this will feel like a uniform distribution. And this is how the third distribution is looking like. So Dirichlet will mean a distribution or distribution, some distribution which is controlling all these distributions. If you figure that part out correctly, you can draw these distributions out. Okay, this is words, or this is like your words per document basically. So what I can also say is, now what about topics? If I wanted to understand topics, or if I wanted to understand, so I'm just saying for topic 0, avocado is almost 0.999. There could be different kind of topic. I'm just mentioning topic 1, topic 2, topic 3. I'm not putting some names right now. Then for topic 1, you can see bacon is my majority, and for topic 2, 0.999, again bread is a majority. Now I am just saying that topic 0, topic 1, and topic 2, if I were to give you a distribution, so if you think about it very carefully, and somehow if I make it such that topic 0 is almost synonymous to avocado and topic 1 is synonymous to bacon and topic 2 is somehow synonymous to bread, can you see in document 3 specifically, and of course there is some Bayesian multiplication happening everywhere, but can you see especially in document 3 itself that it makes sense actually, that this is what the distribution should look like? Yeah, right. And if I say that your topic or your words are nothing, basically just they are samples drawn out from this massive distribution, then basically this is what they are. And this is what I'm trying to show, that at the end of the day, document 3 is nothing. I could just figure out document 3 based on these two charts only. Rather than trying to go word by document, I can get word by topic. This is word by topic, and this is topic by document. And if I were to just multiply them, what I would get?
Word by document.
Sorry, what did you say?
Word by document. Word given document.
Perfect. That's the simplest idea. And this is what latent Dirichlet allocation is all about. Again, you can read his original paper back in 2 and 3, and I can even show you the original paper. Dirichlet allocation. So if someone is interested, I will really encourage you to definitely read this paper, a good paper actually. Okay, and okay, it basically comes from Berkeley, UC Berkeley, and you can basically go there, and they have explained the same thing. They just happen to take different like Poisson distribution and everything, and based on those Dirichlet allocation, they are doing the same maths. Now it is not very different. Once you were to resolve everything, you will come to find the same mathematics is working behind the scenes as well. Okay, and this is what the whole idea is. So you guys can definitely look into it, how to apply it, and if you are interested, and you can look into this paper to understand a bit more about it. Okay, but remember, if you're not very interested in maths, maybe you might not enjoy this paper altogether. But again, it's a very well written paper and very well explained as well. Now the process is pretty long. I'm not going into the whole process because again, no one actually has to physically do these things. and it doesn't make any sense. So the basic idea is very simple. Again, at the end of the day, it is parameter selection. It is trying to figure out that based on this composite versus topics matrix, the idea is which topics to get relevance and which topics to not get relevance. Okay. And it's the same, like document 1 cat contains cats, document 2 contains, or document 1 contains dogs. So the idea is, if I ask you a question, are you a cat person or a dog person? So basically you will have to figure out that there are different topics that might have gotten involved. Okay. And you need to maybe randomly assign these topics to understand how their distribution might be working. Now, based on your topic, or based on your, let's say, topic 0 and topic 1, and cat 0, cat 1, dog 0, dog 1, because there are, let's say, 2 dogs and there are 2 cats. Then basically you need to figure out that, okay, fine, topic 0 or one topic might contain cat as well as dog 1. Other topic also contains cat 1 and dog 0. Okay. So they might be talking about pets or something like that. Okay. So basically you need to again get the count. So for with cat to topic 0, what is the count, and similarly with document to topic, you will have to figure out that probability. Then the idea is very simple. If you want to get this, you just have to multiply or basically try to get this equation right. And if you get the probability right, it's a simple matter of calculation at the end of the day, that whatever the probability value is, we just calculate it. And at the end of the day, once you start doing all these calculation, you will start to get some probability values, that what might be a probability of that word or topic occurring in like T1. So we are trying to determine the topic of T1, and you can figure out that probability. So the idea is, if cat 0 is there and topic 0 is there, then what is the probability at the end of the day? So this can be figured out. Okay.
So one question.
Yeah.
So if I have a document of, let's say, 10,000 words, how does it, what is the seed topic? How does it say these are the topics, or when it is trying to classify? Randomly, how does it, because there are 10,000 words, everything can be a topic. So
oh no, so someone okay, I got it. Okay, so someone of course has to train it first. It is still a machine learning algorithm, right? So the training will happen. It is not a one-shot thing that immediately solves the problem. So I will show you basic training again. So there is something called PyLDA, I guess, if I'm not wrong. Let me show you. Okay, so yeah, so one sec. Okay, so there is a proper library to handle this problem. Okay, so you have to of course train first. Of course, without training, how would it know? So let's say you need to have the train topics or train objects already available with you, and then only it will be able to classify anything. Okay, so yeah, you are right that first you need to know cat belongs to topic 0. Then what is topic 0 or what is topic 1? So either you need to provide it in your data set itself. So again, it's a supervised example. I'm not showing it is completely unsupervised or something. It is still a supervised example that where topics or the major classifications are known to us. Now, based on that, we try to decide which words might be more relevant to, like if you want to decide that, okay, which words are more relevant or which constitute the topic negative, like, okay, which words make or ensure that this topic or this sentence is negative. So if not and not great or something like these words. So through topic modeling, you will come to see these words are of more importance. But how did it figure out it is of more importance? Because of course, the outcome or the outcome class is already provided for us. And based on this latent dirichlet allocation, we can come to seem to figure out the probability of different words related to that topic. Does that make sense?
Yeah. So basically we have to give it a direction on what we are focusing on, so it can start picking from there.
Miss, again, you just give it a supervised data at the end of the day. There is no other task we have to really do here. You just have to provide a supervised data set and it will figure it out, or it will basically calculate the probabilities and it will try to figure out which words might have more sense. Now, again, remember, ideally, you have to remove stop words, for otherwise these stop words will also get involved in different topics, which is not correct. So ideally, you should use stop words properly and ensure that all the stop words are gone. Now, this is a basic configuration. You can use any corpus from Gensim, you can use from NLTK, you can put your own corpus. Okay. And Again, we can use, and ideally we should use PyLDA itself. It's a pretty good tool. Okay, so just let's initialize this thing. Okay, a topic is nothing. The idea is topic is nothing, is just a collection of dominant keywords which are typical representative. Okay. Now, by we as humans, just by looking at these keywords, we can very easily identify what topics is all about. And topics is what is basically a classification or segregation if you think very carefully. Now, remember then what makes kind of or what are the key factors to obtain good segregation topics? The first, quality of text pre-processing. Your text pre-processing should be really good. So all the text pre-processing that we have done, you need to do it here as well. Okay. And variety of topics that text talks about. So if it is different kind of topics that a single text or amount of documents provide, it would be a very key factor in identifying the different topics. Choice of topic modeling algorithm, although here we are just sticking with LDA, we are not going into any other topic modeling algorithm. And number of topics fed to the algorithm. This is one of the major factors. How many numbers of topics you are feeding? And of course, you will have to fine tune the algorithm at some point. So that would be tuning parameters. Now, by using stop words, and you can extend certain words if you want to. So from subject, RE, edu, and use, we are also putting in this stop words list itself. So we put in analytical stop words. And then we kind of read a data set, and you guys can find it on this GitHub. And if I do a control click, it will simply take me here. So it is nothing, it's just a news group data set. What it means is there are different news groups, and each one basically consists of something or some information about a news topic. So let me show you what these things are. So let's say if I were to run this. Okay, so now we get, I guess, 20 topics. Okay, so there are different topics, or they are from different news groups, means they are from different kind of magazines or newspapers. And based on the topics, we have recreational autos like computer system, machine, Mac hardware, computer graphics, space. So these are your topics. Now, if I were to come and ask you, and they have their numerical targets as well. So this is the target name, but they have their numerical target value. So each category has been given a unique number. Now the idea is, okay, so the question will go like this. Okay, the question would be, based on, let's say, content, or based on certain words, can you figure out which topic does it belongs to? Or can you figure out in a reverse way, by reading all the documents, what topics are of most importance for recreational automobiles? Did you get my idea?
Yes, by skimming through some of the.
No, you can skim, but a machine can't.
Yes, yes.
The idea, yeah, you can definitely skim, and we do it all the time. A lot of time when we read blogs, magazines, and whatnot, many times we are not reading word by word. We are not that much interested. So we skim through words and different important keywords, and we try to make sense what it must have written or what must have been written inside. Now, a machine will have to basically calculate a distribution or latent distillate allocation distribution, and basically try to figure out each topic consists of what major words or what major keywords. Okay, so first you will run your basic conversion. Just go through it. If you find it any problem, please let me know immediately. But I think this should be really simple for you.
One question before that.
Yeah.
If you go to line number 5 or 4, actually, let's go up. Yeah. So in the 5, the content, target, and target name. So this target name machine has identified, or we have given it. This is the supervised learning data.
Sorry, I'm not getting what part.
The target names. These are the target names given, or these are given by us, or machine has identified.
No, this is a supervised data, right? So of course it is already available to us. See, in
Yeah.
this
So
JSON, it will be slightly hard to see. Maybe I should. This is why I'm not reading it from a JSON. It's slightly hard to see, but from this JSON itself, if you break down the structure, there are three columns basically. One is the content of the email or whatever the content, whatever the text is. Then there is a numerical target, and then there is the name is also given actually.
Got that. So this is the training data, if I can put it in the machine learning.
Yeah, of course.
Okay.
So after you do the basic conversion, so let's say if I hit the conversion here. So as you can see, most of them are just RE, means regex, which is solving the problem. Okay, so let's read this one small topic. Now it has killed a lot of things. From where is my thing? Subject, what car is this? So someone is asking what car is this? Now it came from a standard some university of okay, I'm forgetting which university is this. Okay, so this has definitely come from some server. Okay, and this is the University of Maryland, College Parks. Okay, sorry. Okay, and 15. I was wondering if anyone out there could enlighten me on this car. It was a two-door sports car, looked to be from front late 60s, early 70s. It was called a Bricklin. The doors were really small. In addition, the front bumper was separate from rest of body. This is all I know. And if anyone can tell me a model name, engine specs, years of production, where is this car made, history, or whatever info you can have on this funky looking car, please email. Thanks. I was bought to whatever it is. Okay. Now, what do you think this topic belongs to? Even if I do not tell you the final answer.
Car.
Yeah, it belongs to
Car.
sector.
Automobile.
So even if I wanted to do a simple search, and this is the car basically they're talking about, Bricklin SV1 basically. So that this one almost feels like it is unattached to the car or it is almost outside, okay? So this is what the Bricklin is. So if you were to just normally come across, and remember, this is an old data set, 1986, and like these are like a bit old data sets. So at that point, internet was not a big thing. So people, if internet or some way of communication was there, people will just simply try to ask. This is Bricklin basically. Okay, a very famous car actually in USA. And, so that now, okay. So if I were to simply ask you, if you were to read this one in one go, what do you think the topic here is? It has something to do with automobiles, cars, right? Similarly, if I were to ask you the another one, okay, from reading this one, what can you conclude here? Subject, genocide is caused by atheism, organization, distribution, world, NNPP, posting host, Frank Doyle in articles, writes in article, Frank Doyle. And you can see there are a lot of special symbols. We will have to kill these special symbols as well. I forget the origin of the quote. I gotta use the words when I talk to you. And atheism is who lacks belief in God, yes. If those sin, it is entirely plausible that an atheist could dig Lenin or Lenin to such an extent that it might be considered worship and still be an atheist. Anything else seems to be newspeak. Ask yourself the following question. What would you regard an ardent Nazi as a Republican simply because Germany no longer has a Kaiser? No, because that's based on false dichotomy. There are more options. And you can see these kind of discussions happening on Facebook these days. Okay, means if someone wants to have a sensible discussion, of course. So you go through the whole thing, and even if I were to go through such a post, what do you think I will conclude immediately that what it might be related to? Something to do with atheism, something to do with religion, something to do with global politics, right? Now, again, as I just showed you, even in the previous one and this one, that still it is not totally open for the consumption because there could be still a few things which might throw it off. Okay, so like these kind of symbols, these kind of server names and stuff should definitely be killed immediately. Okay, because those are not going to help our LDA. Okay, so again, what you could do is the good thing is Gensim also has a simple pre-processing. So it removes various punctuations. So, and it can basically remove everything into terms of a tokenization. Okay. So for each sentence, what we do is we apply simple pre-processing and we almost kill any special symbol that is available over there. And it will take some time, but you will see after that, you can almost generate any line. It doesn't matter. Okay. I guess apart from this bracket, not bracket, it is basically list, sorry. It's not a bracket, my bad. So you can see now there are no more special symbols. Everything has been tokenized properly. So for each line, if I wanted to see, you can very easily tell me for the first 5 lines, if I am just showing you, you can tell that all the special symbols have been killed. Okay. Now, if you want, you can go into bigrams and trigrams as well. So GenSim has these models. Again, NLTK also has that. So you can use it anyways. So you can generate your bigrams, trigrams, or anything that might help you. Maybe you want to get closer to the answer by using bigrams or trigrams, not by using a kind of a bag of word approach. Okay. So it basically builds bigrams and trigrams model for each sentence now. Now it will take a bit of time because again, the construction will take time even with this small data set. And you can see your RAM users is going up. 4.22 GB is already used. Now, once it is done almost, it will release the RAM altogether. Okay, it's done. Now we basically come up with small functions to remove stop words, convert into bigrams and trigrams, and limitize everything. Okay. And once you run all of these, basically again, these are just function definitions. And then basically you can run along with stop words. You can make bigrams, and then you can load the taggers, so which will allow for lemmatization. So species lemmatization is also pretty good. Now lemmatization requires, and I will basically the idea is you will require to allow what kind of things you want to consider. So I want to consider noun, adjective, verb, and adverbs. Okay. So that will ensure that the correct form is taken. Again, this will take a bit of time. It's tricky. Okay. Okay, so the RAM users has not really increased, but this limitation part will take a bit of time. And this is why I told you that stemming, even if it is not accurate, because it is so fast, we kind of prefer stemming, but lemmatization now, this is still a small data set. Okay. So it is working, but lemmatization does seems to take a lot of time. So you have to be very careful with that. Now, basically, this is just trying to calculate all the basic ID to word, and then basically ID to word to doc to BOW means bag of words. It is just trying to get the corpus. It is just trying to understand which word belongs in which topic or which document. Okay, so it is assigning a number to each word, unique word, and it's trying to get a topic modeling. And based on these frequencies, now you can see each one is getting its own word, and it is usually canonical in order. So for this one, now there are basically numbers associated. So this is the frequency basically, that how many times the word has been used. The car has been used like 5 times. So even just by looking generally, what do you think is very important here?
Car.
Car is definitely important. Now, of course, there are other things. Door is, you can see door has been repeated twice, and look has been repeated. Now, look can actually have two meanings, but look has been used twice. And if I were to generate a LDA model, okay, so even in GenSim, there is a LDA model available, and LDA Davis also has this LDA model. Now, based on your corpus and ID to words, basically that will provide numbers to each word, which is just a frequency. Now you need to decide how many topics you want. Okay, let's say 20 topics. Now this came from where? Because it's a supervised data, and in the actual supervised data, there were actually 20 classes available. Okay, and fine. So let's run this LDA model now. So this above LDA model is built with 20 different topics. Again, 20 different topics means 20 different classes that have been provided in the data set. And once it will be run and once it will be constructed, you will see this.
So while this is happening, one question.
Yeah.
So in this command, where is it linking to the previous topics given, those 20 topics? I know
Oh,
the
no,
num
no,
topic.
it doesn't know anything about that. It just knows there are 20 topics that I have to distribute all of the words into, or all of the keywords into.
So this is not linking to the the training data we gave earlier for topic
Yeah,
rank.
no. But the funny thing is, once I will show you topics, you will realize they exactly match with the actual labels.
Okay.
That would be the proof of concept for you, or that would be kind of a proof that this topic modeling actually works. Given large data set, means you can of course fail it in if you just provide like 3 or 4 lines, and you can see it is taking okay. So you know what, because it is already run previously, I can at least show you the results. Okay, so once we run any line or any document, what it does, it provides the probability of different words which might be important and which might not be important. Okay, now based on this, it can be very easily categorized into different topics, and this chart has been generated already, ran and everything. Basically from that one, basically this is what has been found, that in automobile, these topics usually take the upper hand: car, power, light, drive, mount, controller, cool, engine, back, turn. Similarly, in the religious documents or religious emails, God, evidence, Christian, belief, reason, faith, exist, Bible, claim, take more of a bigger number. And you can generate it on your own time, and you can definitely visualize all of these blobs and everything. I hope it has run. Yeah, it has run. So Now, again, you are right that you did not go and manually tell it which topic. You just told there are 20 topics, and that is what you had to do. Because once I run it, now we can see keyword for each topic. So there would be 20 topics. So you will see the major keywords that are very important for each topic. Now I cannot tell, okay, so there would be a number here, okay, and this is how I will know. Okay, so 0 is a topic. I do not know this topic means what. I have zero idea. Okay, let me be very clear here. It has printed out topics and it has given you, I think, the first 10, right? Yeah, first 10 keywords with their relative importance in that building that topic. Now, if I just were to ask you what this topic 0 could be, or if topic 0 is not clear, what this topic 1 is, just by reading the plain words, can you tell me what it could be?
Religion.
Something religious, you will not be very far wrong. And similarly, if I were to ask you topic 3, what do you think this is?
Something related to computer.
Yeah, I can very easily say it is something related to computers. This might be related to what? Space, fine. And similarly, you can go, this might be related to governance. Again, no one went ahead and told the machine or LDA mechanism which topic it is. It was just told, look, there are 20 topics. And for each topic, it came out with top 10 words with their relative importance. Okay, basically the Bayesian or the probabilistic update. That's all it is.
And this is across all these 20 topic, which has the grouping of these words. This is across the whole document, which was
all the documents, yes. By going through all the documents, and they have 20 classifications earlier, it has been able to come up with these terms and given the relative importance and telling you top 10 words for each topic. Now it doesn't know, it has no correct understanding which topic is what. Again, understand this. But this inference has to be made by you, or you can correlate it with the actual data that whatever your actual topics were. But it has been able to figure out 20 different topics, and in each one it has been able to figure out top 10 words or keywords which might define, but relatively you can understand I will have to play a bit of hooky. I will not be able to immediately do it, but just by guessing it properly, I can also very easily tell you which it belongs to which topic.
So one question on this, I can understand, or at least I think I can understand how this probability is coming, but how does it group the word that these words have to be grouped together for the topic?
Yeah, but again, it's a distillate, right? At the end of the day, it is distillate. So basically, even if you do not tell it, what it does is, or what it understands at the end of the day is, now again, there is a complicated nuanced way of looking at LDA, and that's why I'm not going into it immediately. Okay, so what it does, it basically knows there is a document and it must, okay, so any document will be consisting of words. And these words can be broken down into various topics. Now you're told there are 20 topics, okay? Now, basically in each graph, there would be, let's say for topics words versus topic, there would be 20 of these bars. And it is trying to identify based on probability, which one is occurring more regularly, okay? So let's say this is topic 0. So initially it will start randomly, of course. There is no way of it knowing where did it start with. Topic 3 and so far till topic 19, maybe something like that. And based on this probabilistic update, it will get probabilities of various words. And let's say we are trying to just denote the first 10 or 20 terms in each topic and just show the relative frequency or relative probability back to you. So the idea is, you might be thinking that how did this happen? So, okay, so if you remember very carefully, if words given document was what? Probability of words given topic, right? Into probability of topic given word documents, right? So if you randomly initialize and you can switch it like this, that basically you can say, or it is a smart switch basically, words given topics would be then what? Now by applying this, you can figure out what would be the probability of words given topics. If you already know what is the probability of words given documents, which can be calculated because again, all the documents and all the words are already available. So it's a matter of calculation now.
But sir, what if one word will be repeated in several topics?
Fine, that can happen. No one is saying that somehow it will completely come up with a disjoint version. No, it can very easily happen. Hit word, like the word hit, can definitely be in some other group. I'm not saying that that can't happen. Definitely it can. If I were, rather than using only top 10 words, if I were to show you top 25 words, you will see there is some overlap. And that is where the error happens in machine learning. If you'd like to think in those terms, that's where the error will start to happen, because it's very easy now. If I can get my topic modeling right, I can just get top 25 words and I can just do a massive feature reduction immediately based on these topics. And if all of them are disjoint, then there should not be any classification error. But again, we understand that it will not be the case in most of the time. More topics or more words you try to figure out, there would be some overlap. Okay, so maybe technology is one word which might get repeated in different sections as well. You will have to go up and down to find, there might be a chance, or maybe I need to just show you top 25, top 30 words. And then you will see a lot of words are overlapping, and that will happen. That will happen, no doubt.
So yeah, so for example, hit came across, let's say, in 3-4 different topics, and might be there a different probability assigned to it. So
Yes,
that can happen. But why I'm still not very clear. It might be it is mathematical. That's why it is difficult to explain. Also, that how does this grouping happen? Let's say 14 is grouping of patient family. So how does it cluster these things together? But like what I said, it could be
got it. No, don't worry about that. Don't worry about that. Okay, so you understand this idea, right? Let me actually go in the upper ones. Now, if I were to assume, okay, just to tell you like this, okay, see, the target is given, right? We understand there is a target available already. So what if I just say in initial days, I just say one document belong to one topic only. Let's say, although this is not correct actually, but let's say with topics to documents, the list goes like this, okay? Whatever the document is, whatever, let's say document one, it contains, let's say, only one topic. Imagine that it only contains topic number 7. Document 2 contains only topic number 4. Okay, now again, sorry about this diagram. This is not a very good one. But imagine this is already known to us, or this is the basic assumption you are already making, that okay, fine, but a document will still be dealing with a single topic. Let's make that assumption. You will have to come up with some assumption at some point. So now you can get a topic related to document.
This is anyway pre-assigned, isn't this? Is a training set. So
yeah, this is something you can calculate, not pre-assigned. You will have to still calculate this, but yeah. Imagining that one document here, again, this is the assumption, maybe I forgot to tell you, but each document or each row that you are looking, the idea is it is assigned to a single topic right now. You cannot have the target, there are no multiple targets. So what I'm trying to say here is, I can very easily say one document only deals with one topic. So does not give me the whole distribution already, topic with document or topic with respect to document.
yeah, so the question is, this content target and target name. This target name is manually assigned by us
No. Understand. This has no meaning actually. Okay, I can kill this whole column and it will have no problem. Okay, the simple assumption is, okay, forget this number and name. Okay, do not think about this. Do not think about this. Just imagine doc 1, doc 0. randomly assign some number, maybe contains topic 0. And again, a lot of other documents, maybe doc 39 also contains topic 0.
And this is assigned by whom? The machine initially randomly.
Sorry, yeah, machine will randomly initialize this.
Okay.
And then it will start trying to match the probability distribution. Now, if both of them, doc 39 or doc 0, happen to have topic 0, let's assume, what would be one another thing that will happen with both of these?
A lot of words with the same probability will be there with them.
Yeah, or I can say their Dirichlet is going to be very similar to each other. If doc 39 or doc 0 has certain Dirichlet, doc 39 Dirichlet is also going to be very similar.
Yeah.
That is what I'm trying to tell.
Okay.
Okay, so I know there is bit of mathematics. It takes time to get inside the complete idea. But yeah, it doesn't actually deals with, because otherwise I could have gotten the direct names here, right? If it was totally supervised or something. Why I'm getting printing it 6? Again, I have no idea who 6 belongs to what, although I can guess it, no doubt. I can definitely guess what it might belong to. But the machine doesn't actually knows what it is. It just knows, look, there is definitely a different topic because its distribution looks very different from the other ones.
Yeah. So if you
and based on the distribution, I can very confidently, or the machine can give you a very high probability and maybe throw out top 10 words with their different relative probabilities.
Got that. Got that. Makes sense. So if I had said, give me split that into 40 topics, then this would have been even more thematic.
Yeah, if you tell it 40, it will generate 40 topics. Now, it might not make sense, but it will generate 40 topics. You can also give it just 2 topics.
Yeah, but that will become even more difficult to.
It will be, for a machine, it will become more difficult. It is like that clustering problem, right? If you do not figure out the correct K, I have shown you like visually over there what can happen. You have to figure out correct K, or you will have to use some other techniques. Otherwise, it will just keep on doing the grouping anyways you want. But would it make sense? That's the problem.
Okay. Got that.
Okay. And the idea is, although I have generated this one, so based on the top 10 keywords or something, and you can figure it out that with automobiles, maybe these top 10 words are available. With religion, these 10 words. Again, this is a guess. Again, I'm telling you very, very carefully that I cannot tell you what it might be exactly. But if I already know what the data set contains, I can maybe make a very good reasonable assumption.
So the alignment of medical or sports is manually done once we know the grouping.
Yeah, this part, it will generate topic 0, topic 3, something like that. But based on my own knowledge, I can very easily summarize it to the correct topic. Or basically here, if I know the Dirichlet allocation, but if I already had some kind of a labeling in my original data, it would not be very hard to kind of do a reverse thing, reverse mapping as well, to figure out if these topics occur in which documents, and these documents have what target names. It would not be very hard for me to figure it out. Okay, but sometimes, okay, this was a very cute data set where each document or each email only deals with one topic. Let's say a lot of documents actually deal with a lot of different topics at the same time. So then the clarification might not be that easier. And again, you will have to either have to do guess, or you will have to construct a standard vocabulary that ideally these terms usually deal in these kind of topics. Okay, but understand, the machine has no understanding what these top 19 number topic means. It just does a probability calculation for you. That's all. Inference is done by you, very much by you.
Okay.
Okay. All right. So in topic modeling, LDA does happens to be, I'm not sure this will work right now. It takes a lot of time. So PyLDA actually can generate a very great, how do I say, visualization, but it takes sometimes so much time that it is very frustrating after a while. So if it works, then great. Otherwise, we will have to wait. Okay. Did it work? Yeah, great. This is what I wanted to show you. So if you select a certain topic, and you can go and, you can select new topics, it will actually give you amazing visualization. And this is something I want you definitely to understand properly. But again, it is just a probability of frequency distribution, that's all. So what it is saying is for topic 1, there are top 30 most relevant terms for topic 1. Okay, and okay, sorry. So line means it is just, again, remember, this is just 24.2% of all the tokens, okay, which are relevant. Line, would, write. Now you can see this is line like would should have been replaced by me, okay, I should have been able to kill, because again, this is why I'm telling you this is very important. Be, get, go, these words cannot be topics. This is wrong. S, however it appeared, I am not sure. Could, just can't be. Organization, yes, it's a very good word, no doubt. Good is okay, think is okay, make is also okay, time is also okay, host is also okay. Again, I can keep going down. Much, well, things, come, say, have, really, we, need. Okay. So now you can see that basically you can do these topic modelings, or you can do this scaling basically. And again, you can generate different topics, like this is topic 2, and then again you can go for next topic, and you will come up with some good use cases and some good terms, and it will be feeling like a small cluster at different points. And this is what it is trying to show back to you. Okay. So remember, the red one is, so okay, blue one is overall term frequency, and the red one is estimated term frequency within the selected topic. Okay. So ensure that, again, I'm just ensure that kill a lot of these words. Okay. Okay. Otherwise, most highly frequent and these words. Otherwise, you might really struggle in getting the correct tags, because it will just get the probability immediately. And if you were to choose part or something like that, let me show you. Okay, so you can see that they're relative as well as with each topic. So blue is again overall term frequency, and when I go to some red one, and the larger it is, it basically means it is a very good identifier. Like need, again, need, the word itself is very frequent, but with some topic 2 or something, it is not that useful, because you can see the percentage or the estimated term frequency within the selected topic is actually very less. Again, need is like, again, some word, highly frequent occurring word, which can actually be killed as well. So this is something that is amazing, and I personally like to look and kind of visualize a lot of different topics according to this one as well. And I will ask you guys to do the same. Okay. So that's why we use PyLDA Davis, especially for this visualization and visualization only. Okay, and you can see here government, attack, country, death, soldier, women, murder. I can very easily say it has something to do with international affairs. And these are PCs basically. So this is principal component 1 and 2, of course, so that at least okay. Okay, all right, fine. So this was the basic idea of LDA, or basically topic modeling, and how can you utilize it. Okay, so once you do this, and of course make sure to try to just generate a distribution or try to generate a proper visualization in order to understand how or which terms are more important. Okay. Now what is part of speech? This has to do with your normal standard English grammar, basically. So I told you there is something called part of speech very early, and I told you that it will come later actually in practice.
This is how we form a sentence, like noun, verb,
Yeah,
adjective.
so basically any sentence is formed, and there are different parts of speech such as verb, noun, objects, verb modifiers, adverbs, and everything. Okay, or compound adverbs. So the idea is basically we have been given this idea of grammar, and we understand which is a noun, which is a verb, and everything. So in corpus linguistic, and this is a Wikipedia definition to be very honest, part of speech tagging or POS tagging or post is a grammatical tagging or a word category disambiguation. Okay, so basically to make each text or each word in token or each token corresponding to particular part of speech based on both its definition and context, a relationship. So the idea is to explain this idea or to understand this idea, these different words actually belong to different parts of English grammar or different rules of English grammar, and we need to tag it properly. Okay, so you need to tag each word or each token or group. It could be also a group, actually it might be a phrase as well, into forms of like noun, verbs, adjectives, adverbs, and etc. Okay, now remember, it is much more complicated. It's not that simple actually, because again context matters. We have shown you the basic idea of word sense disambiguation, like a word like bear, right? So bear might have two meanings, or like bull market might have two meanings itself, right? Depending on the context, you will need to choose the correct one. So you cannot have a generic mapping. It's almost impossible. Okay, you just cannot have a generic mapping, and to do any kind of POS tagging, basically it is required when I am doing text to speech conversation or even speech to text. We need to understand, like they refuse to permit us to obtain the refuse permit. See the permit and refuse, how they have been used very amazingly in the two ways. Okay, word sense disambiguation is, she saw a bear and your efforts will bear fruit. So you can tell this is noun, this bear is noun, but this is a verb. We can tell very easily because we understand these grammatical rules, and we understanding and we have basic sense of context very fast. Okay, but how does NLP or a machine understand this? Okay, so NLTK basically has this massive list. Basically, it has a massive list of POS tags, and this is the a pretty big list of NLTK POS tags. CC is coordinating conjunction, CD is cardinal digit, DT is determiners. Okay, so there is a massive list, and you can choose to read it on your own time. Okay, but the idea is there must be a way, or there should be an idea. Now it's actually very easy to do in NLTK itself. Again, introduce punct over there, and there is something called average perceptron tagger, and in that one tag you will get something called POS tag. Now unzip it. Now ideally you should tokenize word by word because you want to get it, and then using nltk.tag use POS tag, and that will solve your problem immediately. Now this is the test string we are gonna use. Okay, European authorities fined Google a record of $5.1 billion on Wednesday for abusing its power in the mobile phone market and ordered the company to alter its practices. Okay, and let's see and what happens now. Now again, even I find it very hard to remember because again there are such a big list, but you can understand, you can look at the normal ones like nouns and these things. Okay, and you can try to see that phone and a lot of other words, it basically gets correct. I think this is conjunction cardinal. So conjunctions, these are conjunctions. Okay, and you might have to look into different, again, the whole list. Again, I have a habit of forgetting this list all the time. So it's very hard. Like there are verbs itself, the verb base form, VBD is the past tense, VBG is the gerund or present, VBN is the past participle, and VBB is singular present. and VBZ is third person singular. So you can understand it's hard for me to remember all of these. So you will have to go through the whole list and then recognize. So NN is noun singular, NNS is noun plural. Okay, so it is pretty good. If you do it correctly, it is actually pretty good. And by generating these POS tags, it would be easier. And one of the good ideas of using a POS tag is in lemmatization itself, where if you provide the correct POS tags, or if you provide these correct POS, the lemmatization is far better, okay? Because then it knows what to do with these rules, okay? So one of the habits that you can get into it to get the context as well is to use the POS tags, and based on the correct POS tags, you will be able to figure out what might be is used in the whole sentence. Okay, now these have been made by a lot of dictionary rules and a lot of heuristic optimization, which I'm not going to cover, to be honest, because that is going to just make things very complicated. But the good news is you can simply use nltk.tag, import POS tag, and that will generate all the part of speech for you. Okay. Sorry, someone said something, I did not get that. Okay. Now the problem is, but still POS tag will limit you. Okay, POS tag can still be very limiting at the end of the day. What is more interesting, at least for me, is named entity recognition. What is named entity recognition is something similar to POS tag. The idea is, if I see a noun, mostly a noun, can you tell me what it is exactly? Like firing Mr. Store's person, that is given, that is amazing. However, removes a favorite target of Mr. Trump, that is another person, from the ranks of FBI. Now that is a group. GP means mostly a group. Okay, FBI, GP is, and Christopher A. Ray is person, a chance to move beyond the president's eye. Now this is something very important. This is information that you really want, and you will realize in a lot of examples, rather than doing a POS tagging, you actually want NER. So named entity recognition is probably the first step toward information extraction that seeks to locate and classify names, entities into predefined classes such as person, organization, location, expression of time, quantities, monetary values, percentages. And then again, NER is used in a lot of NLP fields right now, and it can be what kind of companies you mentioned in the news article, were there any specified. So if you want to do some real-time analytics, NER is one thing that you need to understand. Were there a specified product mentioned in the complaints or the reviews itself? Does the tweet contain the name of a person? Does the tweet contain this person's location as well? Now to do this, this is where Spacey rules. Okay, literally there is nothing better than this right now. At least whatever I have seen. You will have to install a Spacey immediately. Okay, now remember, there is a corpus on which it has been trained. It is called onto 5 nodes 5 corpus, and you can find this one is okay. So you can go ahead and maybe if you want to download this corpus, you are more than free to do this. Again, releasing back in 2013 actually. Okay, and on this one, they have been able to train, and it is available in Arabic. So this is mostly news. Okay, news, web portals, telephones, pivots, and everything. And you have English and Chinese. Okay, mostly it is still best for English itself. Now, based on this, what they have done is, or what Spacey has done is, they have come up with these massive LSTMs, which are trained on these onto 5 nodes, so basically corpus. And over there, everything has been defined very clearly that this name means this is the person's name, this is a group's name. So it's a classification for, at the end of the day, for Spacey's internal model, or sorry, model is just a classification. Okay. So basically, you have to import the core web SM from Spacey, and you will just have to load it. Okay. And whenever you load any document, okay, you just pass into the NLP. This is the load of the English core web SM. And over there, you will be able to get the organization or whatever it is, you will be able to figure out. So Now Spacey has different names, right? One sec. Wait, let me show you what Spacey NER does. Or actually, I am just forgetting some of the groups actually. So it is called named entity recognizer, or the models have been made available openly. Okay. Now understand these are basically just neural networks. Internally, it is neural network. Okay. So let's see. So you run the entity recognizer. It is referred as ENT, basically ENT. So you can give a call over there and it can run the things. I am just trying to look what are the major outputs that it throws out. So ID is the NER. Okay, fine. That is fine. Okay, so this is the basic idea and this is the whole problem. So entity recognizer, but it will take me to the same place. So there's a list of objects or things it can detect basically. So I know it can detect your location, it can get your group, it can get non-profitable or organization, something like that. It can definitely get a person if the person has been mentioned, okay, in the onto 5 data set. So if it is some kind of world celebrity, there's a high chance it will be able to detect that. Okay, so you can see when I ran this NORP, I'm forgetting what's this full NORP is okay, sorry, I'm definitely forgetting what it means, but it figures it out that European authorities means something to relate with some organization which has regional power. Google means organization, 5.1 billion is money, and Wednesday is a date. Now you understand how powerful this is. If you can do this successfully in your data set, identifying sentiment, identifying the correct classification also becomes very easy, because there is not much ambiguity after this one. If NER provides you, and again, remember, it is an internal neural network model which runs, but if it does this very beautifully, there should not be any problem.
So just a question. So is there, so basically if we have NER, that clubbed with part of speech and that clubbed with sentiment analysis and all those, then it becomes a very human-like thing. That
NER is fine. A part of speech we might not be able to help you that much, because again, look, at the end of the day, you will have to write a lot of rule engines to solve this problem. Okay. The more rule engines you write, then the part of machine learning goes away, right? Then machine is not learning, you are making it, giving it rules. And again, there are so many ways English language have been used, and something which was true for Shakespearean time or his writing is not true for modern English. Something which goes on Twitter is not correct or consistent with standard English books.
domain specific, it might become very
Yeah, but
powerful.
again, someone has to do all this hard work, right? I
Yeah.
understand. I get the sentiment, what you are trying to express. Even I have thought about this. But then I think that goes against the whole philosophy of machine learning and deep learning. If I'm trying to manually learn all the rules and provide it to machine, then I'm just going against the philosophy of machine learning, because the idea of machine learning and deep learning is all of these dependencies can be learned given a large amount of data. And when you are yourself providing rules, now rules happen to be brittle. So how do I say brittle? As in, means you make one or two changes and the rules do not work after that. Understand? If I just switch the orderings of words, then the rules are almost useless. So that is the whole problem that both kind of become anti to each other. Like if you go too much model free, so deep learning could be called model free, means there are very less rules or structure over there. But then it is highly dependent on data and it can encode biases of data itself. If you go more rule based, fine, you might not have biases, but when we will change some of the data and if it doesn't falls under standard rules, then your system stops working. So there is no one right answer here. And of course, people try to come up with a hybrid approach all the time. And yeah, I think that's the way to go. But yeah, there is no one rule that I can tell you that, yeah, you can always use NER or you can always use pure tagging. because sometimes it can actually prove very restrictive in the way deep learning or machine learning works. But using NER or POS tagging, actually I can make up very good rule engines which can solve maybe a lot of edge cases. Okay, that definitely can be done, and people do that very regularly.
Okay. Yeah.
Okay, now Beautiful Soup you have to learn on your own. It's a very good tool to kind of strip data from websites. Okay. Now the idea is once I run, basically it is to convert from URL to string. We will run Beautiful Soup and the HTML5 library. Okay. And it will be able to split, or it will be able to separate out the text from an article. So if I were to go on this article and if I do Control plus click, one sec, if I see, sorry, it didn't open. Let's see if Control plus click. Oh, this is what it was. Sorry, no. Okay, so this is an old article. At one point I read in New York Times. This collapses. Now understand, there would be a lot of things that is not required. Okay, we are just worried about this text if we can get it correctly. So this is the old one, August 13 to 18. Okay, and again, I guess you guys can know, you might know already how to inspect the element and where is the text available. Okay, so you can go over there and you can also try to figure out the exact text and everything. And this is the console, and maybe I can just do the page source inspection. Yeah, fine. So when you stay here in between these HTML tags, you can come up to read the special content or the content. Okay, this is what you just have to strip down. Rest of these scripts and everything is not really important for us. A lot of these JavaScripts are not important for us. Okay, we just want the content, and rest everything we have to ignore. Now for this one, you will have to learn Beautiful Soup on your own. I cannot spend that much time, but I can just tell you that it is gonna strip all these tags, and it is just gonna, this code is just gonna take out only the things which are the major content, or which are the main content. And if I were to run this, so it will connect on this website, it will try to take out these major, and this is the length of the words that it has been able to figure out. And if I were, yeah, so this is the whole list. Okay, so there are different labels when it finds. So there are cardinal, date, GP is group if I'm not wrong, global, okay, LOC is location, NORP is some non-profit, ordinals, okay, organization, and person. So it figures out there are 153 instances of NER, named entity recognition, that it could do, and it has figured it out. And which are most frequent, you can also get a counter from Python, and that can give you that it is about Peter Strauss, FBI, and Trump, of course. And you can see a single line. Maybe you can start with a single line first of all. And now again it changes. So maybe I can change the line this time, and I can say maybe line number 5. And you can see that maybe it is the first address, or maybe it is something like. So let's try to find the, yeah. So FBI has been under tremendous, immense political pressure by Mr. Trump to dismiss Mr. Strauss, who was removed last summer from the staff of special counsels, Robert S. Mueller III. Okay, so let's try to see, and let's put the same number. That what are the NERs that it has been able to detect. So when it does the NLP, and if you choose display C render, it will do is NER, and now it figures out something. Do you find this NER is good enough?
Yeah.
Yeah, all of them, it got definitely right. FBI is an organization, Trump is a person, Stoke is a person. Last summer refers to definitely a date, okay? And Robert S. Mueller III is also a person. So it got all of them right, actually. You can display, again, generate a complete map of this, that how things are connected, although it will not help much. Okay, maybe, actually, sorry, choose the line which has a lot of dependencies. Okay, and this is how it basically detects. Again, internally also it is doing the POS. Okay, it is not completely free from the POS itself, and it has been able to generate how things are connected, all the words, how they are connected. And this is amazing, right? If you think that rather than me making all the rules, Spacey can very easily do it for you, that how things basically get connected word after word and token after token. That's just amazing. And I can go over by all the lemma and the punctuations as well. And you can see president is a noun, president repeatedly is adverb. And again, you can generate all the POS tags through Spacey itself. And again, it can be generated. Now, wherever it is not available, it would be empty mostly. Okay. And if you want to do it for the whole document itself, you can run, rather than running on one by one, you can run on all the sentence class, or it will basically contain everything. And let me show you the complete text. So this is the complete news article. Now, most of it will get it right. And okay, so this is clearly I have not been able to kill this one properly. So this should have been actually killed properly, or like removed. Okay, fine. And you can keep reading about it, and most of it will make sense, or most of the NER will look very correct to you. Some places it misses out. I will not say it will, like here it should have gotten FBI correctly, but maybe because of this dot and this double inverted commas, there has been a problem, and this is why Mr. Stokes also didn't get caught. But in most places you will not have problems, and you will see it does catches it perfectly. Now remember, these things, like especially for person, it mostly works very well if there are some international celebrity or something, because if it is something local or something, it might not detect very well. Okay, because again, the training of NER or the Spaces NER model has been done on a onto 5 data set, onto 5 nodes data set, and that might not contain maybe your name. Okay, so if you want to find your name, it might be a bit tricky. One time I was doing a presentation for my client and I just generated this one, something similar actually, using Spacey, and they were like blown away. They were like, my goodness, how good is this thing? I was like, yeah, fine. Yeah, you can do something. But remember, if you want to go into a very specific domain, or maybe this will not yield results so good like what you are reading. It is very good for some online article.
Spacey site, sorry.
Yeah.
So Spacey site allows us to create domain-specific named entities.
There are some already data sets and already models which are domain specific. I don't remember they allow us for retraining on something or not. I've never actually retrained any Spacey model actually. So you might have to look into that, that does it allow for some specific retraining or not. Again, I can always find the GitHub available. So it is not that I can't figure it out, but is it officially available? I don't remember. But there are always ways we can figure out what models they are internally using, and we can definitely retrain them. So yeah, retraining can work. I'm just not remembering that it is officially supported.
Okay.
But yeah, to use it in any domain, yeah, your intuition is correct. It has to be retrained.
Okay, thanks.
Okay, guys, so this kind of marks the end of all the major topics, and tomorrow maybe for so tomorrow's class will not be that long. Miss, you can ask whatever questions you want, and mostly I will be showing you a few examples how to use it with classification examples and stuff, and then we'll be basically finishing up this module by tomorrow, and your NLP section will be completely done. Okay. So if you have any questions, you can again revise all the topics in meantime. And if you have any questions, you can bring them tomorrow or bring them forward tomorrow. I will try to answer all of them. And I will try to explain some basic use cases, how to utilize them. And again, understand NLP is a pretty big world. There are so many other things that we do not teach here or do not cover. So at the end of the day, it is your curiosity, that how curious you are to understand the even more nitty-gritties of these things and the statistical nature of NLP. I have already uploaded like a couple of books, so those are amazing books to understand and work with NLP techniques. So why don't you go ahead and start reading on your own as well, because that's how your knowledge will actually increase. And you will have to apply, so you will have to find different case studies or small projects to solve these problems and apply your intelligence. And again, the best way is this beautiful soup, okay? Honestly, just if you do not find any good data set, don't worry. Just go ahead and just start scraping websites at the end of the day. Understand? Just start scraping websites. That's all you need to do. Just do this, okay? Learn beautiful soup properly. So go ahead and learn beautiful soup on your own time and start scraping the websites. That's how you can collect a lot of training data or testing data on your own. Okay, so I'll be closing session for today. I have already uploaded this file, so you can find this one in your Google Classroom, and I will really encourage you